All right, everyone. This is a video to finish the lecture on the material from Trig Assignment number 7. Pick up where we left off. In class, we had finished problem 9, and we were about to look at number 10. Find x rounded to 1 decimal place. Okay. Great. Well, this should be no problem because those are similar triangles, and we know the length of one of the sides there. So let me see what I can sketch over here. Okay, so here's the two triangles, and if I just take triangle 1 and rotate it, it will be similar to triangle 2. I'm told that this height right here, or this length, is 130, and this is pi over 3, and so this angle here is also pi over 3. However, what they stated was that this was pi over 6. And they want to know what this length x is. Okay, well, if I were to draw each of these triangles, then this one here with the angle of pi over 3, and let's call it R1 for the radius, has R1 sine of pi over 3 equal to 130. And the other triangle has R2 cosine of pi over 3 equal to 130. Okay, super. So I should be able to label these edges. Let's see how I want to do this. Make some room here. Okay, so this is R1 and this is R2, and this dimension is R1 cosine pi over 3. And this one is R2 sine pi over 3. And I know, and what I know is that R1 sine of pi over 3 is equal to 130. But that's the same number as R2 cosine pi over 3. Okie doke. So then it must be the case that tangent of pi over 3 is equal to R2 over R1. Okay, I don't know if that's helpful. We'll see here in a second. Well, tangent of pi over 3 is just the square root of 3. Okay, not helpful yet. Except for we would now know that R2 is equal to R1 square root of 3. Okay, so then I could replace this R2 with R1 square root of 3. And I know the cosine of pi over 3. It's 1/2. And I know the sine of pi root over 3, it is square root of 3 over 2. So then this just says 3/2 of R1. So I got 1/2 of R1 and 3/2 of R1. Therefore, it just equals 2R1. So x must be 2 times R1. I'm hesitant here because I just saw a different, perhaps a different approach that would have been better. We'll see. But this length is 2R1, but let me point out that that's a 90-degree angle right there. So then R1 squared plus R2 squared is equal to 2R1 is equal to 4R1 squared. And of course that uncovers the... Okay, well, so what? So what? I gotta use this 130 somehow. Oh, well, I guess I don't need to mess with this anymore because here I can solve for R1 and get a number. R1 must be 130 over the sine of pi over 3, which is square root of 3 over 2. So R1 is 260 over root 3. And since that length is 2R1, we would have that x is equal to 520 over root 3. There was probably a shorter path to getting that done, but whatever, that gets it done. Find x rounded to 1 decimal place. Okay. And you've got this, I forget what this is called, where we start stacking these triangles like this to form this petal. It's like a flower petal. But this should be totally doable. So I have that the first triangle with a side of 35 this being a right angle, and this is pi over 3, and we'll call this hypotenuse R1, then 35 is equal to R1 sine of pi over 3. And sine of pi over 3 is square root of 3 over 2, so this is R1 square root of 3 over 2. Okay, super. The next triangle is still a right triangle, but then this angle here is 65 degrees. So then in radians, that'd be times pi over 180 degrees. Okay, 65 divided by 180 is 13/36. So this angle is 13 over 36 pi. All right, and I know that this length here is 70 over root 3, because when you solve this for R1, it says R1 is equal to 2 over root 3 times 35. Okay, and then this is x, and so what we can say is that x sine of 13 over 36 pi is equal to 70 over root 3. In which case x is just equal to 70 over root 3 times the cosecant of 13 over 36 pi. And you just figure it out to 1 decimal place. I'm sure you can do that in your calculator. See what else we got happening here. The angle of elevation from the top of a very tall building is found to be 8 degrees. From the ground at a distance of 1 mile from the base of the building. Okay. I'm making a drawing. Using this information, find the height of the building. No sweat. So what we know is that this angle is 8 over 180 pi, and this distance is 1 mile. And we are supposed to find the height of the building. Well then, tangent of 8 over, let's simplify 8 over 180. That's 2/45. So the tangent of 2 over 45 pi must be equal to x over 1, which is just x. Now this would be in miles, and they want us to calculate it in feet. So we would need to multiply by 5280 feet over 1 mile. And then we are just multiplying by 1 right here because those two quantities are equal. The units cancel, and boom. So tangent of 2/45 pi is 5280x. Then consequently 1 over 5280 times tangent 2/45 pi, that's x. Sweet. All right. A water tower is located 350 feet from a building. From some window in the building, an observer notes that the angle of elevation to the top of the tower is 39 degrees, and the angle of depression to the bottom is 25 degrees. And then they're going to know how tall is the tower, how high is the window. Oh, how high off the ground is the window. Okay, no problem. Let's make a drawing. I mean, they already have a drawing there, so maybe I can just draw on top of that. So let me get a picture of it. All right, here's our situation. And for us, in this scenario, x is 350. So this would be 350 feet. Eey, that doesn't look good. 350 feet. Okay, so that means this black dashed line is 350 feet. Okay. Let's see. So, I mean, this is a right angle. Yeah. And we want to know what is this height. Let's call it h. And we want to know this height right here. We'll call it j. Okay, let me think. Well, clearly, well, because it's not that clear. Let's see, what can I do? Let's break up this into two pieces and call this one H1 and this one is H2. Then I guess correspondingly I need to call this R1 and this R2, the length of the radii. Well, then I would have that 350 is equal to R1 cosine 39 over 180 pi but that's the same thing as R2 cosine of negative 25 over 180 pi. Okay. Super. And well, what are we supposed to do? Just round to the nearest foot? I mean, you could just plug this into your calculator. In fact, that seems about as good a deal as anything. So R1 would equal to 350 over cosine 39 over 180 pi, and R2 is equal to 350 over cosine of negative 25 over 180. Well, 25 over 180 should simplify. So that'd be 536 pi. So now I know R1 and R2, they're those numbers. So this is, just to write it more compactly here, I'll say this is 350 secant. I'll just say 39 degrees. I submit to your will. I'm sure you probably were doing that the whole time. So this is 350 secant minus 25 degrees. Okay, and oh, well, look at that. J is H2. Okay, that's handy. I guess we'll just figure that one out first. So since J is H2, that's the height of the window. Then H2, oh, come on. H2 must be equal to 350 secant minus 25 degrees that's R, that's the radius, but then it would be times sine of minus 25 degrees. Now secant times sine, that's tangent. Okay. Bang. So there, I can get H2 there. It's that number, whatever number that is. Then H1 would be 350 secant 39 degrees. That's the radius. And then sine 39 degrees. There was probably a way for me to recognize that tangent was going to pop out here anyways. Can I see how that would be? Let's see if we can figure out how tangent would have shown up anyways. Going back to this being R1 and R2, then looking at the triangle on top, then R1 tangent 39 degrees would be H1 over 350. Actually, sorry, I don't even need the R1 because tangent is the slope. That's probably where we should have just started. Tangent is the slope of this line. The tangent of 39 is the slope of this line, and the tangent of minus 25 is the slope of this line. And then the answer is immediate. That's a heck of a lot easier. See how that tangent comes in handy? An airplane is flying, oh boy, at an elevation of 5,150 feet, 5,150, directly above a straight highway, okay? Two motorists what are they doing? Are driving cars on the opposite sides of, are driving cars on the highway on opposite sides of the plane. The angle of depression to one car is 32 degrees and to the other is 51. How far apart are the cars? No problem. Let's make a sketch. Here's our road, and here is our ugly airplane. And the cars are driving towards each other. Wow, I guess that's like a minivan or a bus. And then all right, and okay, and this one can see the airplane, and this one can see the airplane. And since the airplane is in level flight, the angle of depression to one of the cars is 32 degrees and to the other one is 51 degrees. How far apart are the two cars? So what I really should have done here was say, I should have brought these two lines together at the same point. So the witness is there, and then this is 32 degrees, and this is 51 degrees. Okay, awesome. And well, I can drop a perpendicular right here, then that becomes a right angle. And since that angle is 51, then it must be the case that this angle is 51. And with this angle being 32, it must be the case that this angle is 32. Okay, so I don't need any of that anymore. What now? Oh, the airplane has an elevation of 5150 feet, so this is 5150. We wouldn't have been able to solve the problem without that. Boy, this looks like a tangent. Let's call this L1, and we'll call this L2. Then the tangent of 51 is 5150 over L1. I guess we'll just solve it. So L1 is well, tangent of 51 is rise over run, and so I'd have 5150 over tangent 51. And we have that L2 would be 5150 over tangent 32. And you just add them together. And that's the assignment.